Hello, humans. Hello.
Whoa, did we go live?
Mm-hmm. You told
Oh,
me to
okay.
push the button.
I did. I did. Did I tell you?
Yes.
Did I remind you?
It was both simultaneously.
Good. Well, then we're live, and it feels like it just worked.
It
What?
did
So,
today.
what was the problem? How did you solve the problem?
I logged everything out. I logged everything back in, and it was happier. I'm there. There was a zombie cookie, is my guess.
Huh. Right. And so it was storing some malformed state.
Yeah, and I logged everything out. I rebooted. I logged everything back in.
So right now, it's warning: the stream's current bitrate, 5,800 kilobits per second, is lower than the recommended bitrate. We recommend that you use a stream bitrate of 4,500 kilobits per second. So we're above the bitrate, but it's warning us.
It can't math.
No, it's fine, YouTube. It's fine. It's just fine. So why are we doing this today? Oh, that's right. You're heading out. You're going to be gone.
Yeah. Last April, I thought it would be a really good idea to go on a vacation for my birthday, to use up hotel points that were like, we don't care that there is a pandemic. We are going to expire.
Yeah.
And so...
Too bad for you. Yeah.
I am escaping the invasion of mice that is the reality of my house and visiting the big mouse in Florida.
Oh, awesome. Yeah, that's a fun place. The absolute best part of the whole thing was when you're in the Epcot Center and you go, they have like a restaurant there where they showcase various interesting hydroponic, like it's like a fresh vegetable restaurant. But then they have this boat tour that you can take behind the scenes where they take you to all the little inner hydroponic gardens where they grow everything. And there's like a tomato tree that's many years old and yet it's still producing tomatoes off of it. It's gigantic, like fills a room, and it's got tomatoes hanging from it, like some, I don't know, some kind of anime or something.
The thing that didn't occur to me until I went to China, that I've also seen done in that particular boat tour, is in other countries, they recognize that vines are meant to climb things, including watermelon and squash.
Yeah.
And so here, like, if I wanted to grow a pumpkin, it would eat half my yard.
Yeah.
There, they have what looks like a grape trellis.
Yes.
But with giant ass zucchinis hanging down.
I've done that. Yeah. You can do that with cucumbers, with zucchinis, with watermelons, you just have to support them. So once it produces a gourd, you have to give it like a little bra, like a little bag that hangs and supports the weight of the gourd as it grows.
Yeah.
And then it will absolutely go vertical and gives you a tiny amount of space. And in fact, you can match things together. So you can grow, say, a zucchini up a tree.
Yes.
And it can support itself on the various branches of the tree. So yeah, it's pretty cool. But it's just great to see all this hydroponic technology. Like that felt like practical space exploration to me when you see all this stuff behind the scenes. And they actually do a ton of this at Epcot Center.
Yeah. Epcot is really awesome. And the other thing, the ride that goes up within that giant golf ball, I think it's called Spaceship Earth. They have in going through the history of the space era, they have, and I'm terrible with names, there's this very famous African American woman who was inspired to go into NASA by Michelle Nichols.
Okay.
She's done as an animatronic in a mini skirt and tall platform boots with an amazing afro. And I love the triple whammy of scientist at NASA in super high-tech setting in totally 1970s awesome
Right.
Legs are required to be miles long, attire, and then it's an African American woman with fabulous hair.
That's funny.
It was just like, it was perfection.
So, for those of you who are wondering what it is that you have stumbled into, we're about to do an episode of Astronomy Cast. So, we'll do the show. We'll take about half an hour, and then we will stick around and answer your questions about space or astronomy. Mae Jemison says, Katrina Astro YYZ. Yeah.
I thought Mae Jemison was an astronaut.
She's an astronaut, yeah.
Yeah, no, this was a woman who
it's like a
did
scientist.
calculations and worked in mission control.
Okay.
Yeah, no, different human.
Okay. Let's begin. Tell me when you're ready.
I am checking my audio hardware settings because Audition is being mad at me. If it's not one piece of tech, it's another. He nods, sagely agreeing. Yes.
I feel like you wrestling with audio software is just a trope of this channel.
Yeah.
My trope is wrestling with audio hardware, and yours is wrestling with audio software.
This is true.
Mm-hmm.
All right. Today is 662?
3.
Oh, geez. Okay. I knew that. I did know that. I forgot that.
Don't overwrite the previous episode.
It won't actually let me, luckily.
No.
All right. So I have pressed the record and I have pressed the other record, and we are recording, sir.
Okay. Right. I have to do my job. Okay, here we go. Astronomy Cast, episode 663, the end of the year events. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. How are you?
Good. I mean, I could whine about weather, but I won't.
Are you going to have a white Christmas?
Probably. Yeah. I mean, we're going to have a white December just all the way through. So, last year was bonkers. This year is shaping up to be just this side of weird. But now I just feel like every year the weather is just weird. That's just the new normal.
I saw Blue Jays.
You saw Blue Jays?
I saw Blue Jays. Blue Jays mean winter. Robins mean summer.
Yeah.
So it's going to be a cold one when the Blue Jays are here.
Right. Now, we generally save our stargazing selections for the summer when it's warmer in the northern hemisphere. But you're tough. You can handle a little cold, and it's worth it because there are some wonderful things you can see in the night sky this time of year. And we'll talk about it in a second, but it's time for a break. And we're back. Have we ever done this? I was sort of thinking about this. I was writing my introduction. I'm like, yeah, every year, every couple of years, we give our last episode before we go on hiatus. We give you a bunch of recommendations to see over the summer, and we drag out all the common things. But we don't do one this time of year. And that's crazy because there's a ton of really interesting things, especially this year, that we should highlight. And so, you know what? I think our listeners are tough. They can handle it. They can handle some cold outside weather when they just take some extra hot chocolate and
or extreme
just
heat
warmly.
if they're in Australia.
Right, exactly. Yeah. Are we avoiding the extreme heat? I mean, I guess it's it's a milder and cooler and nicer in July in Australia as well. But yeah. So what interesting event is coming up? Well, I guess let's talk about some transitory events, some things that are brand new and fresh, and then maybe we can shift over to some stuff that you can expect to see every year around this time. So what is interesting that's going to be happening this winter?
Well, right now we have Mars at opposition, which means that Mars is rising a little bit after sunset. The nights are quite long, so Mars is rising a little bit after sunset. It's setting a little bit before sunrise, and it's pretty much at its highest point in the sky at the middle of the night, which time zone dependent may or may not be midnight where you are. But this means that that giant red dot in the sky could be Antares, could be Betelgeuse, or could be Mars.
I mean, if you go
And
outside right now and you live in very light polluted skies, you
yes,
will probably see two stars,
yes,
Jupiter and Mars, right? Neither of them are stars, but they are the two brightest objects in the sky right now after the moon. And it's a good way to know. Yeah, if you can see these, if you can see a clear sky and you can see these two objects, yeah, you're looking at Jupiter and Mars, which is amazing.
yes. And it's fun to be able to say to people, hey, did you know there's a world entirely occupied by a troop of robots? Make it sound as spectacular as possible. The Cylons have arrived, and then
Yeah.
it's just Mars. And you can then continue the story pointing out at Jupiter and saying, hey, there's this little mission called Juno going around Jupiter, and they post all their information online. So when we go in to warm up, we can download some data and make beautiful images using a camera that NASA purchased.
So
No
why
purchase
is Mars
required.
opposition so important? What does it mean?
So Mars opposition means that it is a reasonably good time to launch a spacecraft, and it also means that it's easy to monitor it. So if you want to do something where you want quick turnaround time between you and your favorite robot, you aim to have that thing occur during opposition. And if you are aiming to launch a mission toward the red planet, you aim to launch it about now.
And and this is something that is transitory. Mars opposition happens at different times of the year. And when you sort of imagine it in your mind, just imagine you've got the sun, and then you got the Earth, and then you got Mars all lined up.
Yes.
That's opposition. And
Yes.
so Mars is opposite to the sun.
And you don't want to launch precisely at opposition. The Rosalind Franklin rover missed its launch window, which was a little bit earlier in the year. But when you see Mars at opposition, it usually means, hey, a launch window may have just gone by.
Yeah. And typically, a fleet of spacecraft launch
Yes.
every Mars opposition year, but not this year. I don't think anything's gone to Mars this year.
No,
Rosalind
no.
Franklin was supposed to, but of course, the Russia's invasion of Ukraine canceled that because they were going to be providing the launcher. I don't think there's anything left.
And
China
not
hasn't got one. I don't think anybody's launching this year.
And not every opposition is made equal. Not every launch window is made equal. So by definition, you will end up with an opposition every single Earth year. But you don't get an ideal launch window every single year.
And when we're recording this, Mars is going to be passing behind the moon. You're going to get
Yes.
an occultation, but
Yes.
that's going to be happening tonight. And
So
so
go
really,
look for images.
yeah, go look for pictures and videos from people who took it because it happened. But I've got cloudy skies, so I
I
won't be
have
able to see it
clouds.
tonight. Yeah, but I'll have to live vicariously through everybody who took pictures and took video of it. So that's Mars. What else is happening in the sky?
So we have Mars, we have Jupiter, we have the Geminid meteor shower is going to be peaking the week of December 12th. And all because it's peaking on its normal December teen date, depending on which year you're listening to this. That doesn't mean that if you missed the peak night, you shouldn't go looking for meteorites anyways. The radiant is coming out of the constellation of Gemini, so you'll see the meteors appear to radiate out in straight lines away from that constellation statistically more often You're going to see shooting stars all over the sky. And you're also going to see shooting satellites, except they're like on known orbits and it's much less random. So don't be afraid to go check out Heavens Above and find out, is there going to be an International Space Station pass tonight? Is one of the brand new super bright satellite communications satellites going over tonight? Is there a Starlink train tonight? All of these things are a good excuse to get your family outside and talking about something different than what the dog just did. I don't know what
Well, the
your family talks
Geminid,
about.
yeah, I mean, the Geminid meteor shower is the best. Typically, it is the most reliable high volume meteor shower every year. You typically can get upwards of 100 meteors per hour. So a little more than one a minute when you're watching the sky, which is better than the Perseids. I mean, we always rave about the Perseids, but the Geminids are better than the Perseids. And
Perseids get more bullets.
right. Yeah. I mean, there are definitely there's a few weird ones that can give you more bolides, but the Geminids are just like, for raw meteor power, you can't go wrong. It's just, for me and probably for you, it's cold. So you gotta sort of pace yourself when you're outside in that kind of weather. But if you want like guaranteed meteor sightings, the Geminid meteor. Unfortunately, we're not going to have the best moon this year for the Geminids.
If you go out closer to Christmas than to that December roughly 13th peak, you're going to have the moon later and later in the evening and a smaller and smaller fraction of it. So that is at least working in your favor. But you want as little moon as possible when you're looking for shooting stars and aurorae. That's something else you can pay attention to this year. Or any year for that matter.
Well, we'll talk about that in a second, but it's time for another break. And we're back. All right, let's talk about auroras then, because this is maybe not going to be the best year, but we're on our way to better and better years. Why is that?
So we are headed towards solar maximum. In just a few years, our sun's north and south magnetic poles are going to work on flipping themselves and in the process create a maximum number of sunspots on the surface of the sun that we can observe during the day. And periodically, the loops of magnetic field lines that you end up spiraling over the surface of the planet can snap and rearrange themselves, and in the process send a whole bunch of charged particles our direction. And when those charged particles interact with our planet's magnetic field, they streak down in collections, and as they interact with particles in the atmosphere, we will see amazing green and red streaks, a cool additional friend called Steve that looks like a big fence in the sky. It's just an absolutely beautiful thing. It tends to be maximum in likelihood that you're going to see an awesome show in the sky, closer to the equinoxes. But winter nights are long, winter nights can be dark, and check out spaceweather.com to find out how to sign up for alerts and see what auroral activity is predicted for your area of the planet.
And, you know, I go on and on about this, but I really think it's important for a lot of people who are listening to this. They've never seen an aurora in their life. Yeah. And you think that you never can, that you've got to go to Iceland or Alaska, but you actually don't. Like, as long as you live in the northern part of the United States, in the middle of Europe, Japan, in southern Australia, New Zealand, the southern parts of South America, you can see an aurora. You just need to be more organized. Like if you live in Iceland, you walk outside to walk your dog and you look up and, whoa, what a surprise. Another aurora blowing your mind. But for the rest of us, Yeah, the rest of us who live further away from the poles, you just have to be organized about this. So what I recommend, and I recommend this every year, is find an Aurora Alert app. And I apologize, I can't give you a specific recommendation because these things change all the time.
Yes.
Sometimes they're great and then they go offline. And so just like do a search in the App Store for Aurora Alert app, look for websites, just Google it. You can find it. And it will tell you when the space weather strength is growing to the point that you could have auroras in your area. And you need to learn what that's going to be. You know, for me, I need a certain strength. I think it's like 6, 5, and I'll be able to see auroras. And you also want to find a place that gives you a nice view to the north, or if you live in the southern hemisphere, to the south. So for me, for example, I've got a beach that is here on Vancouver Island that I can stand on, and then I can watch straight to the north. I look all the way across this sort of giant gap in the water, and then there's mountains to the north. And so I've got a really nice view to the horizon. It's very dark skies. The city lights are behind me. And every time the Aurora Alert goes off, we pack up all our stuff and we go down to the beach and we wait. And sometimes you just take some pictures and you like maybe you can see a glow off on the horizon, and other times the sky explodes with aurora activity. And yet I've never just gone outside, looked up while I'm walking the dog and thought, wow, aurora. Like each one is required preparation, but you miss 100% of the auroras that you don't try to go see. So
yes,
this is your year. And as we approach the solar maximum, they're just going to get stronger and better, and you're going to have better and better chances to see this. So please, I beg you, install an Aurora Alert app. Get to know what strong space weather events look like in your area. Plan out a place that you can try to view them. And when one of these storms is building, go to your dark sky spot and see what you can see. Take a camera, do some long exposures, and I'll bet you'll even get them. So good luck. I believe in you.
And this is going to sound so lame, but like my recommendation is if you have a friend with a farmhouse surrounded by pasture that has an attic, figure out how to get the north-facing window open, because then you can keep your body inside and your camera pointed outside. And that is honestly one of my favorite ways to do star trail images, is just straight out an attic window.
Awesome. All right, we're going to talk about this some more, but it's time for another break. And we're back. All right, we've talked about Mars. We've talked about the meteor shower. We've talked about auroras. What else should people be looking for this winter?
So one of the cool things that you can do in the December-January timeframe is go outside, and this is a early in the evening thing, and find the constellation Orion. You don't need someplace that is particularly dark. We could just make it out from Cambridge, Massachusetts. Couldn't make it out from downtown Boston, so it can be just like that small of a variation.
Orion? I mean, you could see Orion anywhere, pretty much.
It's from downtown under skyscrapers, right. Not necessarily.
Okay.
But, yeah, you can see it just about everywhere.
Nightmare. Yeah.
But, but like literally not in the financial district. That is my requirement. And underneath that underneath that belt of Orion is the sword. And you probably won't be able to make out the Orion Nebula if you're in a bright place, but you can point out to people that constellation you're looking at, that entire region of the sky is actively forming stars. And if you're someplace darker, you're like, okay, so that smudge in the sword, that is a star-forming area that is in the process this very moment of creating new stars. Now,
I love that process. Like, even if you don't know your way around the night sky, if you've got a pair of binoculars, you can just look around the sky with your eyes, look for anything that's like a little hazy, blobby, fuzzy bit in the sky. And then you point your binoculars at that thing. And it's a thing. You can see the Andromeda galaxy you can see like the double cluster in Perseus. You can see the Orion Nebula. You can see the galaxy in Trapezium.
Yeah.
The Triangulum galaxy. There's a ton of things that you can actually see that you don't realize that these are objects in the night sky, and then you point your binoculars at them and you're like, oh yeah, there it is. Like even with regular binoculars, you look at the Orion Nebula, you totally see where it is.
And what I love about that area of the sky is you then jump from the Orion Nebula to the Pleiades, which looks like someone dipped a cotton ball in white paint and then spludged it onto the sky. And now you're seeing a system that just finished forming stars, that is still blowing the gas and dust out of the star forming region. And as you bump over to Taurus, which is right next to Orion, you now have the Hyades cluster. And that's a open cluster that is in the process of falling apart as the rotation of our galaxy causes some stars to lag behind and others to race ahead. So we have in this area of the sky that you can block with your hands a system that's in the process of still forming, a system that's getting rid of its last remnant gas and dust, and that system that's falling apart. And there's a story there where you can explain this is how astronomers understand how stars form and why the sun is alone.
Yeah, I love that. Like these are baby stars.
Yes.
Everything's shrouded in gas and dust, and stars are just going off like supernovae in this. And then here's an older one where the stars have mostly blown off the surrounding gas and they're starting to clear out their environment. Mm-hmm. And then with Taurus, they've cleared out their environment and now they're drifting away from each other and will be lost in the chaos of the Milky Way.
Yes. And then you can always just point out that someday, hopefully in the next 100,000 years or so, when humans are still hopefully around, Orion, the hunter, will get a bloody red shoulder when Betelgeuse decides to explode.
Right. And even Betelgeuse, I think right now it's brighter than usual, the time that we're recording this.
Yes.
But the variations on Betelgeuse are actually fairly visible. And you can use the other bright stars in Orion to give you a sense of whether it is brighter or dimmer than these other stars. So back when Betelgeuse dimmed several years ago, it was clearly obvious. You walked outside and you're like, weird, Betelgeuse is dim. And so you can do this. You can actually just visually compare and go, okay, Betelgeuse is a little brighter than Rigel or a little less bright than Rigel, and just compare them. And and just like walk outside and just kind of compare the stars. And after a while, you'll build up a sense. You're actually watching the variations on Betelgeuse. And those variations are coming from enormous sunspots that can cover a huge portion of the surface of the star, of burps of gas and dust that are being blobbed out into space and blocking our view to the star. You can make these observations for yourself. It's amazing.
And this is a system where when you go back inside to warm up again, we have actually imaged, in kind of low resolution, but we have imaged the surface of Betelgeuse with interferometers here on the surface of our planet. So this is our one chance to really make out what another star looks like in a similar way to how we look at how our own star, the sun, looks like.
Now, you mentioned briefly that Mars is in the sky, and I talked about how Jupiter's in the sky, but actually all of the planets are in the sky right now.
It's true. Not all of them are easy to see.
Right, especially if you don't have a nice view to the horizon. But over December 2022, just in case you're listening to this into the far, far future, it's possible to see all of the visible planets at various times in the sky. So you can see Mercury close to the horizon. I don't know whether it's after sunset or before sunrise.
So
it switches.
When you listen, it will be different.
You can see Venus. you can see Mars, Jupiter, and Saturn, and they're all visible in the sky right now.
And two super cool things to note is Venus has phases the same way the moon has phases.
Mm-hmm.
And with a modest-sized telescope, you can start to see, oh, that's a crescent Venus. That is a waxing gibbous Venus. It has all these phases. And then the other thing that is fun to surprise people with, but you have to plan ahead because you're not going to randomly figure this out. You can see Neptune with a small telescope. Galileo saw Neptune. He just didn't know he saw Neptune. It was in the field of view of Jupiter and he sketched it out.
That's cool.
Yeah, it's this chance to really take in all the, and I mean Uranus, not Neptune. Uranus. You can see Uranus with a modest telescope, and even Galileo was able to make out Uranus. He just didn't know he had made out Uranus because it was in the field of Jupiter.
Yeah, that's amazing. So were there any other events that you think people should be aware of this winter?
Those are the big ones that are easy to explain. There are two comets that are currently visible, one of which is plunging in, and I'm not going to curse it by naming it, but it is on a cool coming in from above the disk of our solar system, visible. My dog has strong opinions. One moment, please. Why? Why do you do this to me? Go. We have new neighbors with a new dog. And so
that's exciting.
It is. And normally I could lock my dogs in here with me and they wouldn't be able to see people going down the street, so they would be quiet. But now they hear the neighbor's dog barking at people going down. Anyways, there is a comet that has been spotted that is being barked at by Malachi. Okay. There is a comet that has been spotted that is coming in. It's slowly approaching roughly the northern celestial pole, Polaris, in the sky. It's going to dive through our solar system. And it already has a little tiny tail and a bit of a coma. And so there are hints that we're going to have a good comet this year.
Perfect.
Maybe,
let's
hopefully.
Hope so. This is it, 2023. This is a portent of a good year for astronomy. All right, thanks, Pamela.
Thank you so much, Fraser. And thank you so much to all of our patrons out there. Without you, we would not have editors to go back and fix it when I inadvertently rename planets, and we otherwise just have barking dogs and other things like that. Because of you, we are able to pay fair wages and provide insurance where needed to our staff. And this week, I would like to thank Benjamin Mueller, Scott Briggs, Don Mundis, Dean McDaniel, Michael Regan, Omar Del Riviera, Matt Rucker, Janelle, Michelle Cullen, J. Alex Anderson, Schwersum, Peter, Benjamin Carrier, Frode Tannenbaum, Moose and Deer, Antisaur, Bruce Amazine, Jim Magian, Abraham Cottrell, Philip Grand, Father Prax, Mark Stephen Raznak, Cami Razian, Dustin Ralph, Brett Niernap, Dwight Ilk, G-Force 184, Szymanski, Alex Rain, Andrew Stevenson, Gabriel Galfin, James Roger, Paul Hayden, Glenn McDavid, John Aliseth, Benjamin Davies, Sean Matz, the Air Major, Sam Brooks and his mom, Karthik Vekatraman, the Lonely Sand Person, the Mysterious Mark, Bart Flaherty, Dean, Nala, Brian Kelby, Nate Detweiler, Arctic Fox, John Drake, Lou Zealand, Corrine Demtruck, Ganesh Swamathan, Bob Zatsky, Ron Thorson, Jordan Turner, Lee Harborn, Jason Carducus, Robert Hundle, Kim Barron, Frank Stewart, Planetar, Stephen Calfee, Reuben McCarthy, Arthur Latzhall, Paul Esposito, Time Lord Iro, Daniel Donaldson, Ian Abdillah, and Jeff McDonald. Thank you all so much. You are the people that make what we do possible.
Thanks, everyone. We'll see you next week.
Bye-bye. And then they saved.
Don't go anywhere.
I need to figure out how to get my dogs to not hear the neighbor's dogs.
Have a deaf dog. Solved it. That's our solution.
Yeah.
Sometimes we'll have like dogs out there just like barking up a storm, and our dog is just like doesn't know.
Yeah.
Okay.
Okay.
Okay. I'm uploading. Go ahead and post any questions that you might have. Arjun asks, Go ahead. Oh, Arjun asks, are all the stars that we can see with our eyes just really close?
No, because the brightest objects out there we can see to substantially greater distances. So it turns out that when we go outside and we look at things like Betelgeuse, they aren't necessarily the closest things. In fact, while Alpha Centauri is one of the brightest stars in its constellation, it's certainly not one of the brightest stars in the sky, and it's nearby. So
It's pretty bright. Alpha Centauri is on the, I think it's in the top 20, but no, they are, it's not that they're close, it's that they're bright.
They're huge. And
they're huge.
They have a lot of.
And so this idea is like you're seeing this skewed version of the universe because you are seeing, as you said, Betelgeuse, which is whatever, 300 light years away. We're seeing stars out to a few thousand light years away with our eyes. Yeah. And every star that we see in the sky is an unusually hot and bright star, putting out way more radiation than even the sun does. We can only see stars like our sun out to a few dozen light years, and then they fade away with our eyes. You can see them with telescopes.
And I want to thank Orbawa over on Twitch for gifting the sub to the community, and thank you to Sai Wasabi for the sub.
Mitzvahs Gollum asks, curious on what new propellant fuel or systems may be in development to avoid pollution by rockets launched.
There was a plan to create green airplane fuel that I was reading the other day, where they use solar energy to basically reorganize carbon oxygen molecules and water molecules to make jet fuel, that I thought was kind of cool. But I don't know of anything particularly. There's something there's the
Whoa, your mic.
Sorry. Blue Shift Aerospace, I believe, is developing a greener launch.
Yeah. So Zapfan is noting in the comments that hydrogen and oxygen is pretty clean. Of course, that's what the space shuttle flew with on its main shuttle tank.
That's what
SLS uses for its main tank. And the output of that is just water vapor. Yeah. Water vapor in the upper atmosphere could contribute to global warming. Not so great. But yeah, that idea. So with solar power, you can just extract carbon dioxide out of the atmosphere, mix it with water, and make methane. And methane is the rocket fuel that's used by Starship with the Raptor 2 engine. So Elon Musk has said in the past that the long-term vision is that there will be these giant facilities at Starbase
Mm-hmm.
Boca Chica, and it will extract carbon dioxide out of the atmosphere, make the rocket fuel on site, and then they will use that to power the rockets. And so your rockets are carbon neutral.
Yeah.
But it's just so expensive to do that. It's way cheaper to just buy your methane in a truck, So I wouldn't be surprised if it's a long time before we see that. The other thing is they wouldn't necessarily be about zero carbon, but like the current solid rocket boosters put out a ton of really nasty chemicals, very dangerous chemicals. And people are working on methods of building solid rocket boosters that don't put out nasty chemicals. So that's another possibility as well. Lionel says, Elon Musk says a lot of things. So many things.
It's true.
He does. He says a lot of stuff. Arjun says, maybe we should start climate change on Mars with rocket launches. Well, the idea to terraform Mars is to use chlorofluorocarbons. So if you dumped chlorofluorocarbons into the atmosphere of Mars, they actually make really good greenhouse gases.
The issue that you run into is there's just not enough gravity or a magnetic field to hold on to a thicker atmosphere. It had a thick atmosphere before. It lost it. It will lose it again.
People think it's pretty hilarious that you said waxing gibbons. Not waxing gibbous. So, you know the difference, right?
One's a monkey.
Yeah, we don't wax gibbons.
Good. They might object.
It might make you go faster. If you want gibbons sliding down the snow slope, you wax them up. They move fast.
I did not get enough sleep last night.
Well, it's okay. It's all right. I didn't catch it either. So it flew right past me.
You caught a different mispronunciation I had.
Yeah. Arjun asks, will Starship be loud and bright as SLS?
Yeah.
Yeah, louder and brighter.
Yeah. I saw a science fact that disturbed me a bit the other day. We don't hear our sun because there is the vacuum of space between us and the sun. But if we could, it would sound like jackhammers. And because sunlight and sound move at two very different speeds, the light from the sun would end after 8 minutes if the sun spontaneously went away, but it could take 13 years for the last of the sound waves to get to us. Yeah.
That's interesting. That's really cool. Hal McKinney asks, would an anti-carbon atom only annihilate with a carbon atom? So do like if you have, like, say, anti-hydrogens, and you collide them with carbon, do you get annihilations at a proton by proton level? You must.
I don't know what the cross sections are. You should get some sort of an annihilation if it's like splat. They if the cross section is right, but I don't know exactly the details of that.
It feels weird to me though that you could have anti-Einsteinium and you wouldn't be able to make it annihilate because it can't find any regular Einsteinium.
Well, it's going to break into other particles before it has a...
Sure. Anti-uranium, right? You need to find only regular uranium to get it to actually annihilate, which seems a little weird to me. But that's just me.
So I'm not thinking of the so it wouldn't be the entire atom in general. It would be strictly the nucleus of the atom that you'd have to worry about that with. But like, I don't know how you get an anti-carbon because that requires a whole lot of antiprotons to
Mhm.
gather together in a very precise way. And I don't know if we've gotten to the point that we can construct that yet.
Yeah. Yeah. Which antiparticles have been made so far?
I know we have helium, but that's easy in the grand scheme of things. But yeah, if you had an atom, yes. If you threw a positive uh, uh, proton at an anti-carbon, there would be destruction if the cross section was correct. What did we
Helium
say?
3 is is the
Okay.
heaviest that's ever been made. 2 protons and 1 neutron.
Okay.
And it looks like someone's done. Actually, you know what? Someone's done
Lithium?
anti-helium 4.
Okay. I want a lithium.
Yeah. Arjone asks, does the sun get a lot of its heat from positron annihilation, since that is part of the fusion process? Is it?
Yeah, you do get the. Yes, that is part of it. I don't know the breakdown of the sources of energy in the sun. I know I calculated that once as a homework problem. That is not anything I have remembered since I did the homework problem.
But it's kind of like asking like how much of the Earth's heat comes from radioactive decay inside the planet and how much is coming from the leftover cooling down of its formation.
Yeah. And
Yeah.
that's a surprising. Well, no. So there's the PPE chain. Um, if I have the right set of letters, is one of the nuclear reaction things going
Mm.
on in the core of the sun.
Well, I don't see any more questions. You have any questions over there on Twitch?
I just see good humans.
Just chatting happily. Well, then maybe it's time for a rant.
Okay, go for it.
I don't have one.
I'm mostly just sleepy today. And apparently talking about waxing gibbons.
Exactly. Yeah. So someone can suggest a rant to me, and I will gladly rant. But I'm trying to think of an observation. Okay, I'll give you an observation. So as a content creator, we are. It's a like obviously it's like first world problems, but when you read your comments, you read your emails, you read the tweets that come at you, it is like this low grade toxicity that
Yes.
is nonstop,
Constant.
constant, never ending. And it is the emotional labor that comes from doing this job that we have to do this all the time. Like imagine you had a job where trolls said nasty things to you while you were doing your work all day long. And it requires a very resilient personality
Yes.
to endure it.
Yes.
And even me, like I am resilient, I am positive, but still you just like you read these Facebook comments and you're just like, oh God.
Our first year recording, I'm going to let them all, I'm going to remind them of a story I bring up every few years because I am still like in awe of you doing this. We had only been recording for a few months. There's a specific genre of hate mail that we finally seem to have stopped getting, or people are just making go away before I see it. And that was the genre of, Dear Fraser, you need to get rid of Pamela. She's too glib.
Right.
And that's like the TLDR version. And it always came from someone who said, my degree is not in astronomy, but... And they always had like a physics or an engineering degree. And they always demanded I apologize and offered to be the co-host.
Right.
And one of the first times we got one of these, I was like, baby professor, early 30s. And I'm sitting there and I've read it and I'm trying to figure out how to respond and I'm going to apologize. And I'm like, oh my God, I'm terrible. I need to, and I'm
Yeah.
going through like all the stages of imposter syndrome and grief.
Yeah.
And then up pops Fraser's response, which was something along the lines of, Dear Sir, we provide this for free. Can I suggest? And then it basically boiled down to, now go the fuck away.
Yeah. Pound sand.
Yeah.
Yeah.
That was
No one's forcing you to listen to this.
it was glorious.
Yeah.
And
Yeah.
it's just like, oh yeah, we
Yeah.
don't get paid to do this.
Yeah. Yeah. And so but I want to recommend a balm. I want to recommend a healing salve that will restore your faith in humanity. And so there's a little known thing that I do is that I interview my patrons. So every
Oh.
single person who signs up as a patron for me at Universe Today gets an email saying, hey, can I interview you? And
That's awesome.
about a third of the people will take me up on this offer, and it sort of blows their mind that, yes, it's actually me. I'm right here talking to them for 15 minutes, asking them a bunch of questions and just kind of generally chatting. And it is so heartwarming because you get to talk to this person and they're not a troll. They've got a life, they've got kids, they've got a job. Maybe they're an astronomer. They're discovering interesting things. They've got really fun hobbies. They've taken the time out of their busy schedule to kick a couple of bucks your way.
Yeah.
And you get a chance to talk to them. And it is so wonderful. And I walk out of each one of these conversations going like, people are the best. Right?
That's awesome. We do office hours with Astronomy Cast and CosmoQuest that I do Sunday afternoons.
Yeah.
And do you play games with your Discord audience at all?
Mm-mm.
Yeah, no. We have a CosmoQuest Minecraft server that before I pinched a nerve in my neck, and now like my hours for being on a computer each day are limited. But like sitting and just playing Minecraft and building amazing things with a whole group of like other science nerds. So we're discussing science nerdery while like just doing a wholesome game.
Yeah. And so I think that what the internet does wonderfully is sort of two things, right? On the one hand, it brings this low grade spite and hate and trolls right into your cortex.
Yeah.
That there's no avoiding it. Like there's no getting around it. There's no way that I can just spend a day and not have like maybe 40 or 50 low grade shitty things said to me.
Yeah.
But it also lets us make connections with people who are wonderful. Mm-hmm. And we place all this emphasis on the 1.1%. Like if I look at the like to dislike ratio on my videos, right? They're 98.3, 99.1% like to dislike. People like your stuff. But our brains want to hear the bad news. Our brains want to hear the threats, the risks.
And we're used to false positivity, and so we believe only the negative.
Yeah. I mean, it just feeds right into our imposter syndrome and so on. And I think double down on finding your tribe, on finding people who you like and who you enjoy their company online. And every time that way you can have a negative interaction with somebody, but you can also have a day's worth of positive interactions with people and you can sort of build that up. And then the same thing about just being like I worry, and I see even happening in my own life, just as we get more and more used to living our lives online, we less and less have to go out and spend time with other human beings in our community.
Yeah.
But what we're replacing sitting around outside the fire with a beer, chatting with your buddies, is just this low grade toxicity. It's not healthy for our brains. Oh, what do you know? Look what just came into our chat on YouTube.
What came into our chat?
Oh,
a troll.
porn bot. Like it's like, imagine if you were aware of your nervous system, of your immune system fight against everything that's going on in your environment.
Yeah.
And every few minutes, your immune system comes to you, goes, well, I just had to fight a bacterial infection and we pulled it off, but there was like a lot of good cells that died. There'll be a funeral at 11 if you want to come. And then, 20 minutes later, your immune system's like, I hate to tell you this, but we found this protozoa in your urine and we killed it, but it was awful, right? You just like, and yet we are conscious of just all the troll attacks that go on in our brains. And
to all the people that moderate for us, you are the only reason we are sane.
Yeah, no kidding. Oh my God. Thank you so much. Yeah. I'm like, oh, moderation. Like, we both run lots of communities. Like, you are just taking you are taking that emotional damage, and other people are throwing themselves in those bullets for you.
Yeah, and the moderation team is our secret service.
Sure, for sure, but it's also causing emotional damage to them, right?
Yes.
And so there's no way around currently, but I do look forward to a future where there are consequences for being a troll, and not like, you go to jail, but like you just get to talk to less people, right? It's just like, oh, here's a troll, the immune system, your AI immune system just whisks that person's interactions away, and you don't even have to deal with it, because in the same way that your immune system's like, we just killed a bacteria, seemed all right, seemed nice, but we just can't have that. We're not letting him get into your brain. And that's what he was trying to do. And he didn't seem to want to do anything wrong, but we have a rule: no bacteria in the brain, please, around these parts. So
it's a good goal.
Anyway, yeah. But anyway, so what's my takeaway? Like, don't be a troll, obviously, but none of you are trolls. But like, consider the negative effect this low grade, just shittiness is having on your brain, and find ways to replace them with high grade, good human interaction, even if that means stepping out of your comfort zone, making new friends, and spending time outside of your house, or even things online, because it matters. So that's it. That was my rant, my sad rant. But anyway, it was sort of rolling around in my brain today as I finished clearing out all of the flat earth assholes from my Facebook comments.
And tonight is Weekly Space Hangout.
That's true.
Do we have a guest tonight?
I don't know. Probably. I'm not that organized. Let me see. I always love it though when I show up and I'm like, oh my God, this is our guest.
I've had that a few times. It's like, camera off, hiding back here, just going to produce.
All right. So we've got Carl Stapelfelt, who took pictures of a really cool hourglass butterfly exoplanet. You've probably seen it. This new from JWST looks like this hourglass with this accretion disk at the very middle of it, and there's like new planets forming in that. And he was one of the researchers that did that picture, and so we'll learn about that picture and the underlying science. Yeah, I'm excited. See, now I've ruined myself. Now I'm spoiled for tonight. So, all right. Thank you, everybody, for hanging out with us here on Astronomy Cast, and thank you, Pamela. And we'll see you all next week.
No,
we won't, because you'll be gone. We'll see you in 2 weeks, 3 weeks. What? Yes. And then when there's like holidays, who knows when we'll see you next? We'll see you at some point in the near or far future. Whoa. Okay, then. Well, then have a good holiday. Have a safe trip, Pamela. Try not to bring back all of these diseases.
Oh, I have so many masks.
So many masks. Mask on top of mask. Yeah, you're gonna be like
that is
you're gonna be
actually
like a
the plan.
biosuit.
I have
Yeah.
the KN95, and then I have
Nice.
a loose cloth hanging over it.
Perfect.
Yeah.
Yeah. Right on.
Sorry. Yes. Mask all the masks, humans.
All right. All right. We'll talk to you later. Thanks, everybody.
Okay.
And we'll see you next year.
Yes.
Bye.
Bye.